Hello everyone, let us start the probability theory for data science. Let us go through the objective. The objective is to introduce the core principles of probability theory and fundamental of statistical techniques and to demonstrate methods for solving practical probability problems and statistical applications. Not limited to that, we will learn many numerical examples along with the theory in probability. We will follow some of these textbooks, a first course in probability by Ross. You may follow any other books also. There are many references here I have given. Kai Chung, Elementary Probability Theory with Stochastic Process, and Fundamental of Applied Probability Theory by Drake, A. Drake, Advanced Engineering Mathematics, Krzyk. Some of these slides or most of these slides you can see that I have already taken this information from this SOMS outline of theory and problems of probability. In this book you will see that many workout examples are there, and the notes, the sequence I have followed from these books by HCSU, HP, and this is named this SOMS outline of theory and probability problems of probability, random variables and random processes, MC Graw-Hill 1997. So many slides I have followed the sequence of these books, so you can follow up these books also. So if you want to go through more details, you can follow some other textbooks. I have also taken many numerical examples from this book, Fundamental of Mathematical Statistics by Sultan Chand and Sons, by S.C. Gupta and V.K. Kapoor. So there are many workout numerical examples. So I have also taken many numerical examples from these books. In these slides you will see. So what we will learn here, the syllabus it is given. The probability, we will start with probability models and axiom, conditioning and Bayes theorem. Also conditional probability we will learn Bayes theorem, independence, discrete random variables and probability mass functions. For discrete random variable we will learn expectation examples, multiple random variable also will learn for discrete random variable. For continuous case we will learn the probability density functions and how independence of random variables it will be defined. For continuous random variable and discrete random variable we will discuss and their expectation examples. Multiple continuous random variable also will learn, and then we will learn the continuous random variable transformation of random variables and covariance correlation between the random variables. Also we will learn the convolution. Then we will finally learn the notion of convergence, weak law of large number, central limit theorems. So basically my plan is to go very slow, so that if you are very new to this topic, suppose you may be expert some other field but you want to learn this topic and you are not as good in this topic because you don't have any background, don't worry. If you see the videos in the lecture, my plan is to go very slow and also with many numerical examples here, many numerical examples for every topic. Whenever we discussed definitions, concepts, theories, whatever, then there are some numerical examples we discussed, so that everybody can understand very clearly, and it is very elementary level, very slow. I have discussed most of the topics I want to discuss. So that is the goal here. So we will go in this way. Let's enjoy the course. Let us discuss what is phenomena. So basically just we want to relate this course to our nature, where we in the surroundings we always see or we always observe, we come across those things. So phenomena refer to a fact, occurrence or circumstance that can be observed or is observable. This is a phenomena. For example, you know that natural phenomena include weather patterns, fogs, thunder, tornadoes, so many more things. So these are the phenomena. So now this phenomena can be classified into two types. One is called non-deterministic phenomena, another is called deterministic phenomena. So what is deterministic phenomena and what is non-deterministic phenomena? So deterministic phenomena is the phenomena that there is a model we assume. So whatever phenomena it is happening surroundings us, we assume that there may be some functional relationship. So that is we say that it is a model. So like there is some cause, so there is some x, it is an independent variable, and there is some effect, some y. So this is the something is happening, some model is there, but this model may or may not be known to us. If the model is known to us and we can perfectly predict it giving the x values, the y we known to it is no y values are known to us given the values of x, so then it is called a deterministic phenomena. So there are many examples in physics and chemistry such deterministic phenomena. Basically exact sciences we try to find that model or function. For example, Boyle's law, Charles' law, there is no ambiguity that there may be many possibilities. So if this law says that under certain conditions, if some conditions are satisfied, then this output will be that. So that is the exact sciences. So in mathematics also a exact science. So one problem is that suppose we are predicting in the future. So mostly future prediction, rainfall prediction, we don't have any model. But in a bank, suppose you keep some money and you know the interest, and after 2 years you know that what will be the value, what will be the final value. So consider the predicting the amount of money in a bank account. So if you know the initial deposit and the interest rate, you can accurately determine the account balance after 1 year. So that is called a exact prediction. So that means you know this function. So this function may be some x into plus some rx by 100. So some function. So if you know the x, then your y is your perfectly you know that. This is called the deterministic phenomena if you have this kind of model. But unfortunately, many natural phenomena, for example, if you just toss a coin, simple, just toss a coin, and then you cannot say that it will be head and tail. So even natural phenomena like rainfall. So if you ask that tomorrow whether there will be rainfall and how much rainfall it will be if it is there. So we can say some percentage. Why we say this percentage? Because we don't have some function that exactly if you give this some of the independent variable, like it may be dependent on humidity, it may be dependent on that particular day, it may be dependent maximum temperature, minimum temperature, and if you have some function like this and you know that either it is yes or no, or it may be how much rainfall it is, then if you give these values, then we can say exactly. But we don't have this model. So then we know that we say that it is a non-deterministic phenomena. So non-deterministic phenomena is that there is no mathematical model that enables perfect prediction of a phenomena's outcome. This phenomena can be divided into two groups. So non-deterministic phenomena is divided into two groups. One is called random phenomena, another is called haphazard phenomena. So basically classification of phenomena, one is non-deterministic, one is deterministic, we discussed. And non-deterministic we cannot we do not have model, but it can be classified into two parts. One is called random phenomena, another is called the haphazard phenomena. So phenomena can be classified into two parts. One is non-deterministic phenomena, another is deterministic phenomena. And deterministic phenomena we have discussed. Non-deterministic phenomena can be classified into two parts. Again, it is random phenomena and haphazard phenomena. So non-deterministic phenomena means we don't have any model to perfect prediction, and deterministic phenomena is that we have the model to perfectly predict it. But this, even if you don't have the perfect prediction, there also we can classify into random and haphazard. So let us discuss how. So basically if we solve this phenomena, actually this is classified into one part is deterministic and another is non-deterministic. Again, non-deterministic part is classified into two non-deterministic, two part. One is called random phenomena. So we can write like this: non-deterministic, this is random phenomena, and another is called haphazard phenomena. So what is those non-deterministic phenomena we can classify? So random phenomena is that this is while individual outcome cannot be predicted in the long term, results exhibit statistical regularity. Basically, this phenomena we don't have any model. Suppose if you are doing a random phenomena, so on phenomena, so whenever we sometimes we do repeat this. So here note that we are considering phenomena whenever we are repeating in the experiment also for a in our laboratory. Suppose you are tossing the coin, so that is also a phenomena. We say that it is a random phenomena. Sometimes we say random experiment also. So for each run, we don't have any model to predict it. But in a long run, there may be some statistical regularity. For example, if you throw a die, so there are 6 faces, 1, 2, 3, 4, 5, 6. Then each time we don't know that what will it will appear. But if we say that after 1000 number of times, how many times 1 will appear? Because if we know that it is a fair die, all are equally likely of the side, then number of times the 1 should appear 1 by 6 into 1000 whenever it is long run. So that is called a statistical regularity. So although the outcome of the single roll is unpredictable, over many rolls each number will appear approximately 1/6 of the times. So this regularity is due to the symmetry of a fair die where each side is equally likely to occur. So, but what is then haphazard phenomena? So haphazard phenomena in the case of outcome are unpredictable and do not exhibit statistical regularity over the log run also. So haphazard phenomena is that, so it is also a non-deterministic phenomena. Each run we cannot predict anything, even if after 1000 or 10,000 number of time you don't have any pattern or statistical regularity. So what are those examples? So for example, instead of throwing a die, you consider that somebody sitting beside the room, and we just ask you say some number from 1 to 6, and this person whatever it is saying the number we are taking as a outcome of the experiment. So then whether after 1000 number of times can we say that how many 1 it will appear, or maybe after 10,000 number of times, because we don't know that this person how he can select this number. Is there any favorite number, any pattern, and after 10,000 number of times also he can change his mind. So it is impossible to predict which number they may choose at any given time. We cannot determine the probability of observing any specific value from 1 to 6. We do not know the person has a favorite number that they choose more frequently. We have no insight into the process by which the person is selecting the numbers. So this kind of things actually it is known as haphazard phenomena. So in a deterministic phenomena, all the exact sciences, mathematics, physics, chemistry, so it is studying finding the exact model for the perfect prediction. But whenever we cannot find the model, either we can leave it or we can find some if we can get some more information, like in the random phenomena. Random phenomena actually we may not have the perfect model, but at least from statistical regularity we can have some information from it. So that is the probability we will learn here. So but the haphazard phenomena actually we cannot do anything because there is no such statistical regularity. Then we cannot actually proceed further with this kind of phenomena. Mostly we will concentrate on the random phenomena, and all possible outcome of a random phenomena it is known as a sample space. So we need to discuss, before defining the probability, we need to discuss some of the definitions, so that we will go through now. So next we will discuss some important definition and of sample space, what is events, and then we will start defining the probability.